So IoT devices and embedded devices in general have sets of sensors. Sensors are the inputs to your device. So sensors are how the device perceives the outside world. So it allows a microcontroller, which we have on a microcontroller on the Arduino, it allows it to receive information from the outside world about the environment. Okay, now the environment, it could be simple stuff like pressing a button, but it could be more complicated aspects of the environment. It depends completely on the type of IoT device that you're making and what kind of environmental conditions you want to sense. So for instance, you can have a sensor that determines how bright it is, right? How bright it is outside, right? You can have a photo sensor. It detects brightness and tells that to the microcontroller. You can have a sensor that detects volume, right? A microphone essentially is what that does. What it does is it'll tell the microcontroller it is this volume, this loud or not, right? What volume it is. Humidity, you can sense humidity, barometric pressure, things like this. You can have sensors for that. These are just a few. Is a button being pressed? So is somebody pressing that button or not? Like on a keyboard or just a button or on-off button, something like that. You can sense if that's being pressed. So this is all information from the outside world that the microcontroller is receiving in order to do its job, right? So say I wanted to detect humidity. Maybe I want to do something. If it's very humid out, I need to do something. So I receive the humidity, and I have some code that says if humidity is above whatever the threshold, then do my operation, something like that. So sensors, and these are just a few of the types of sensors that exist. There are lots of sensors. But somehow, our Arduino, the microcontroller in our Arduino, has to receive data from these sensors. Because it needs to perform different operations based on some aspects of the environment. So, for instance, turning a light on if it's dark out. If it senses that the light outside is too low, the magnitude of the light is too low, maybe it turns on a light. A very simple thing. Or a voice-controlled operation. So if somebody is speaking, then it does an operation, right? So it receives a sound. If sound's above a threshold and matches a certain pattern, then it performs an operation, things like this. So this is what sensors are for. So when it comes to sensing the environment, eventually all this data has to come into the microcontroller, right? Because remember that in our system there's hardware, but the intelligence of the whole system is in this software, this code that you are writing. And this code is running on the microcontroller. So eventually this sensor data has to come into the microcontroller, and then your code has to interpret it. It has to say, oh, if this light magnitude is greater than this, then do something, right? So it's got to come into the microcontroller. But the thing about microcontrollers is that they only sense voltage, okay? That's all they can generally sense. So what I mean by that is, in the Arduino, say you're writing a sketch in Arduino, right? We've already covered this. There's a digital read function that you get. This digital read, you give it a pin number, and that returns the state of a digital pin. It returns if it's low or if it's high. So that is the Arduino reading the voltage on a pin, right? So this is what I'm saying, that the Arduino, it is only, and any microcontroller, it's going to read voltage. It can read digitally, low or high, or you can use analog read on the analog pins anyway, and that reads the analog voltage on a pin. But either way, either digital read or analog read, you are reading the voltage on this pin. Either reading it in binary, high-low, or you're reading the analog value of the voltage. But that's all the microcontroller can do to receive inputs. It can read voltages on pins. Or that's not all, but that's the main way the microcontroller is going to receive data. At least certainly at this stage, receive data from our sensors is through these pins, and it's reading voltage values. So, in order for this to work, in order for sensors to be able to send data to an Arduino or any other microcontroller, that sensor has to take whatever the environmental effect is that it's measuring and turn that into a voltage value, okay, so that the Arduino can read it. So for instance, actually, do I have an example? Actually, before I go on, one example that I might use, I might talk about a light sensor, photosensor, right? A photosensor, maybe it's outputting a voltage according to how bright it is. Okay, you would like to have a component like that. Your sensor has to do that. To take the brightness and turn it into a voltage. Then it can drive that voltage onto a pin of the Arduino. Then in your Arduino code, you can call analog read, see what the voltage is, and then you know how bright it is. Okay? So that's what all these sensors are doing. They're taking some environmental effect and turning it into voltage. Okay? So some of these sensors, actually we'll go through some of these sensors now. Some of these sensors do not directly do that. Okay? A lot of these sensors, they don't output voltage. Okay? Some of these sensors change resistance or do other things. And so it's up to you to make a little circuit that changes, that causes a change in the environment to make a change in voltage. So, let's do an example. Push button. Now, remember a push button, all it does is connect 2 points, 2 wires, right? So this push button, a simple push button, it's got 2 terminals. When the button's not pushed, these 2 terminals are not connected. When you close the switch by pushing the button, the 2 terminals are connected. So you have to, if you want your Arduino to read that push button, you've got to make a circuit so that when you push this button and when you don't push this button, it changes the voltage on a pin of the Arduino. Right? So you get one voltage when the button is not pushed, another voltage when the button is pushed. If you can do that, if you can design such a circuit, then your Arduino can read it and can call digital read and see if it's high or low. Right? So up here on the slide, we've got 2 circuits, the incorrect version and the correct version. Now, let me tell you our goal here in our circuit. We need to make a pin go high when the button is pressed, and go low when the button is not pressed. That's our whole goal. If we can do that, then inside our code, we can call digital read, and we can see if it's low or high and know if the button is pressed or not. Now, the incorrect circuit is a sort of a first sort of simple guess. You can take some Arduino pin, it doesn't matter which digital pin it is, pin 2, whatever, and you can wire that to one side of the push button. Then on the other side of the push button, you can take that and wire that to plus 5 volts to power. Now, this is half good, okay? This is good in the sense that when you press the button, the Arduino pin is then directly connected to the 5 volts. And so when you press the button, it will make that pin high. And that's good. That's half of what we wanted. But the other half of what we wanted is that the Arduino pin should be low when the button is not pressed. And that incorrect circuit does not accomplish that. When the button is not pressed, the Arduino pin isn't connected to anything. So its voltage can float between high and low. We don't know what its voltage is. So we have no guarantee that it's going to be low, so that circuit will not work, or we can't trust it to work, let's say. So that's why it's incorrect. It does half of what we want. It makes sure that when you press the button, it's high, but when you don't press the button, it doesn't have to be low. So that's bad. A better circuit is the correct one. So if you look at the correct one, we wired this Arduino pin in between a resistor and a push button. Now, let's look at what happens when you press the button. When you press the button, you connect the Arduino pin directly to 5 volts. Okay? Actually, that's similar to the incorrect version, right? You connect the Arduino pin directly to 5 volts, and we're happy, right? Because the Arduino pins connect to 5 volts, so when you press the button, the Arduino pin reads high. And notice that that current flow will go from power straight to ground through that resistor. See that resistor down there? It'll go through that resistor. Now, a little bit of current will flow into the Arduino pin, but only very little. The majority of the current will go straight from power to ground. The Arduino pins are made not to take too much current. Okay, so that's what happens when the button's pressed. When the button is not pressed, which was the problem in the incorrect circuit, right? When the button is not pressed, then the Arduino pin is not connected to power, right? Because the button is not pressed, so the switch isn't closed. But the Arduino pin is connected to ground through the resistor, even when the button is not pressed. Now, it's through a resistor, sure. But since there's nothing else that is connected to, its voltage will go to 0. So, because it'll be connected to ground through a resistor. So that's why the correct circuit is correct, because it takes care of what happens when the button is not pressed. When the button is not pressed, the only thing that the Arduino pin is connected to is ground. So when it's not pressed, it'll go to 0 and it'll be low. So that's why the correct circuit is correct. But this is the type of thing we have to do. So notice how this push button we're using as our sensor, right? But this push button does not directly change voltage. It doesn't output a high voltage or low voltage. So we got to make a little circuit, namely the correct circuit, that accomplishes that goal. We got to design a little circuit so when the button is pushed, you get you get 5 volts at the pin, and when the button's not pushed, you get 0 volts at the pin, and that's what we've done. So sometimes with these simple circuits, with simple sensors rather, you have to build a little circuit around the sensor just to make it change voltage so that you can read it in the Arduino. Thank you.